Welcome to the 8.3 notes video over writing the equations of ellipses. There are three things necessary to write the equation of an ellipse: the center, the distance from the center to the vertices, we're calling this A. It is always the one that is bigger than the one in between the center to the co-vertices. When you are looking at an ellipse, the only way to tell the difference between these two is that these are further apart and these are closer together. And then sometimes you only get one of them, but you're given something called the foci. The foci use C as their distance, and there's a formula, c squared equals a squared minus b squared, that we can use to find the missing vertices or co-vertices, whichever one we don't have yet. Pretty much for the equation, you just take a and put it underneath either x squared or y squared. You put a squared underneath them. This is if x has the longer one, like this. This is if y has the longer one, like this. So whichever one actually has the longer side gets it. And then you put b squared under the other one, and it always equals 1. And that's why you're pretty much just trying to decide what these two numbers are. One other thing that's not really typed very well on here is that the center will go in parentheses with x and y right there. And I'll show you what that looks like on some examples. So if you have the graph, find your center first. That's right here, 0, 0. So that means that our equation is going to have just an x squared and just a y squared. You don't really have to worry about any parentheses next to them. Then you count the distance from here to the sides. These are your vertices, and that radius sort of is 1, 2, 3, 4, 5, 6. 6 squared is going to go underneath x, since these are the x values that are changing. And 6 squared is 36. Again, I'm squaring it because that's what it's like in the formula. Then I count the distance between here and here. 1, 2, 3, 4. 4 squared is 16. And my equation is done. Now let's talk about a vertical one. Again, it's still centered right here in the middle of the graph on the origin at 0, 0. So I have another x squared plus y squared equals 1. And then I'm going to count my distance of the longer one first. 1, 2, 3, 4, 5, 6, 7. 7 squared is 49, but since the y values are changing on this one, I'm going to write that 49 underneath the y squared, sorry. X is 1, 2, 3 away, so these are your co-vertices, because it's shorter, just like that. It doesn't actually matter which one you do first, you just have to count in the x direction for x and the y direction for y. And now we have one that is not centered around 0, 0. Instead, it's centered around 1, 2, 3. 1, 2, 3, 4, 5, 6. So 3, negative 6. What that means is we're going to have an x minus 3 in parentheses and a y plus 6 in parentheses. Kind of like when we were doing circles, they just become the opposites in parentheses with the variable that they go to. So this is the x value, it goes with x. This is the y value, it goes with y. Underneath the x's, that distance is 1, 2, 3, 4, 5. 5 squared is 25. And on the y's, it's 1. 1 squared is just 1. So we technically didn't even have to make that one a fraction if we didn't want to. But it's not really worth changing at this point, so I'm just going to leave it. Now let's talk about what happens if you don't have a picture of the graph. So if you don't have a picture of the graph, what you're going to do is find the midpoint between the vertices or co-vertices. It doesn't matter which one you pick, it should be always the same thing. You are either asking yourself what's the middle of them or adding them together and dividing by 2. So, for instance, here, halfway between -5 and 5 is 0. So we have 0, 0. And halfway between these two is also 0. Also, halfway between 0 and 0 is 0. So you don't have to use both of them, but some people like to use this one for whichever one is changing to find the middle. Okay, so this one's pretty simple because if we were to draw this on a graph, here is 0, 0. -5, 0 and 5, 0 would be this way, and this way 5. And the vertices would be up 2 and down 2. So since it's at 0, 0, it's not very hard to count to the vertices and co-vertices. So we already know what the distances are. And since there's no numbers here, this is where I'm going just x squared, y squared, like I did on these two. This is only necessary if you have a center that's not 0, 0. On the bottom, 5 squared is 25, and 2 squared is 4. And we're done. Over here, things are a little different. So if you notice on the vertices, both of the x values are 5. That means the center is 5, comma. And then we have a couple of options here. Either find the middle between 8 and -6, add these together and divide by 2. So 8 plus -6 is 2, divided by 2 is 1. Or if you want kind of a neat trick, the center is always going to be the two that are the same from each type. So it's the 5 because the x's are the same on the vertices, and the 1 from the y values that are the same on the co-vertices, which makes it kind of nice, doesn't it? Okay, now we have to find the distance between here and one of these points. So if you notice the x values are the same, the y values are different. What that means is we're adding 7 in between, or we're subtracting 7 in between. But the difference here, I'm going to call that delta y, is 7. Again, here to here or here to here is 7 away. So what that means is on the bottom of my y fraction, I'm going to put 49, 7 squared, and on the top, y minus 1 squared, because that's where the center and the y value is. Go ahead and write my equals 1 because it's always there at the end. And then I'll talk about my x values for a second. So I can't use my x values here because I don't know how far apart they are yet. I have to use this distance over here. So from 5 to 11, or from 5 to -1, that's a distance of 6. So I would put 36 underneath, and that's going to be x minus 5 squared, because you're using the opposite of the x part of the center. The vertices and the co-vertices can each give you one of the distances. Just like I had to count them both on the graph, I have to calculate them both from the points. One of the numbers should be the same though, so you're really just focusing on the other one. Now, here's an example of vertices and foci, or co-vertices and foci. We need to find the vertices. Okay? First thing you should do is go ahead and find the center. So the center is going to be at 2, comma, halfway between 7 and -9. Well, let's see, that's a distance of 16. So the middle would be subtracting 8 or adding 8, and that would give me -1. Or 7 plus -9 is -2, divided by 2 is -1. If you want to find the middle, just add them together and divide by 2. Now, that I have my center, I can decide how far away my distance for the foci is. So I'm going to call that C. -4 to -2, and -1 to -1, okay? This is the one that's the same, the negative ones. From 2 to -4, that's a distance of 6. Did I make a mistake, guys? Hang on. Yes, this is supposed to be +8. Okay, sorry, that took me a second. I must have mistyped this problem, because it should be a distance of 6 here and a distance of 6 here. One being subtracted and one being added. So that 8 is supposed to be positive. Otherwise, our distance isn't 6 the whole time. And then before I move on to finding these vertices, I'm going to go ahead and say that my difference in the y values over here between the center and the co-vertices is 8. -1 to 7 or -1 to -9, those are each 8 apart. This, because they are my co-vertices, is my b value. Okay, because once again, co-vertices give you b, foci give you c, and we're going to use this formula right here. C squared equals a squared minus b squared. So 36 equals a squared minus b squared, which is 64. C squared equals a squared minus b squared. And then I would add this 64 to the other side. It turns out that 36 plus 64 is 100. And then I square root both sides. So a equals 10. And that's all I needed. I need a, I need b, and I need my center. Because it goes pretty much a, b, center goes up here. B, a, center goes up here. So for my center, this is going to turn into x minus 2 and y plus 1. A is 10. Now all we have to do is decide which letter this goes with. Well, we already know that the change in y is 8, so this would have to be my change in x. It's always, you can't have both be y, so if this is 10, this is going to turn into 100. And if this is 8, my 64 is going to go down here. There we go. Now let's talk about vertices and foci. It's going to be the same thing, except instead of knowing B, we're going to know A. So let's talk center. The 6's are the same, so we know that our center is going to end in a 6. And halfway between 0 and -10 is -5. 0 plus -10 is -10, divided by 2 is -5. Then I'm going to find my distance while I'm here at it. So my y values are the same, so I can't find the change in y, but I can find the change in x. -5 to 0, or from -5 to -10, is a change of 5, or a distance of 5. Again, this symbol is just saying like the distance between the x values, or it's called the change in. So it's the change in x from here to here, or from here to here. Over here, for my foci, again, the 6's are the same. -2 to -8. We're trying to figure out how far both of those are away from -5, or find their middle and figure out how far apart it is. So -5 to -2 is a distance of 3. And over here, since we knew the change in x from the vertices, vertices always give you a. So that means that a equals 5. So we're going to use this formula again. C squared is, or C is 3, so this is going to be 9. A is 5, and I'm just going to go ahead and write that as 25, sorry. And then we're going to subtract this 25 to the other side. That makes negative 16, which is okay, because there's also a negative in front of the b. So really we can divide this whole thing by negative 1, and they both turn back into positives. What number squared is 16? 4. So now we have our A, our B, and our center. Those are really the 3 things you need. Your center, your A, and your B. This 4th thing was just how to find A or B if you didn't have both of them to start with. So, x plus 5, because the center starts at negative 5, and y minus 6. The change in x was the 5, so this is going to become 25, which means that this one is the change in y. Which you don't have to write that down, because that's the only one left you haven't used. 4 squared is 16, and then it equals 1. So really, you're just figuring out how far apart are the x's from the center, how far apart are the y's from the center, and this is always 1. Oh, and the center goes up here.